Picture this, a world with sprawling lakes and rivers and even vast seas. But here's the catch. They're not filled with water. Instead, imagine them brimming with liquid methane. This is Titan, Saturn's largest moon, a place that echoes Earth in its landscapes, but with a decidedly alien twist. Welcome to Cosmos in a Pod Space and Astronomy series. Today we're taking a deep dive into Titan, the only moon in our solar system known to have a dense atmosphere and these incredible liquid bodies on its surface.
What makes Titan so captivating is how it challenges our preconceived notions of what a habitable world could look like. We often fixate on liquid water as a necessity for life, but Titan throws a curveball, suggesting that other liquids like methane could also be in play.
Okay, before we get lost in the methane seas, let's start with some Titan basics. I've heard it's surprisingly large, even bigger than a planet.
You're absolutely right. Titan's diameter actually surpasses that of the planet Mercury. It orbits Saturn at a distance of about 1.2 million kilometers.
And unlike most moons, it boasts a remarkably thick atmosphere, right?
Exactly. Titan's atmosphere is about 1.5 times thicker than Earth's and composed primarily of nitrogen, just like ours. But here's where things get interesting. It also contains a significant amount of methane.
So that's where this whole liquid methane wonderland comes into play.
Precisely. Titan's surface is incredibly frigid, averaging around negative 290 degrees Fahrenheit. At these temperatures, methane and ethane, which exist as gases on Earth, transition into a liquid state.
So we're talking actual bodies of liquid methane, lakes, rivers, even seas.
Absolutely. There's a massive sea on Titan called Kraken Mare, stretching over 1,000 kilometers across. To put that into perspective, it's larger than the entire state of Texas, a sea of methane.
That's mind-boggling. Okay, we have methane seas, but does Titan also have methane weather? Does it rain methane?
Now we're getting to the truly fascinating part. Titan possesses a methane cycle that closely mirrors Earth's water cycle. Methane evaporates from those lakes, and the seas forms clouds in the atmosphere and then precipitates back down as methane rain.
So you could experience a methane rainstorm on Titan. That's wild.
It is. And much like Earth, Titan experiences seasons across its 29.5-year orbit around the Sun. These seasons influence the methane cycle, leading to fluctuations in rainfall and lake levels.
All right, we've got this mind-blowing methane cycle going on. What about the landscape itself? What's it like on Titan's surface?
It's a strange juxtaposition of the familiar and the alien. You'd find sand dunes, but instead of being composed of silicates like on Earth, they're made from hydrocarbon particles.
Huh?
You also have mountains and canyons likely carved over eons from rock-hard water ice.
Water ice. So there is water on Titan.
Yes, but the extreme cold keeps it frozen solid. We'll delve into the possibility of liquid water deeper down a bit later.
Okay, I'm following you. So we have mountains, canyons, and hydrocarbon dunes. Anything else notable about Titan's surface?
One striking feature is the relative lack of impact craters, indicating that Titan's surface is geologically young and active, which is quite unusual for a moon.
That is interesting. And what about that famous orange haze?
Yeah.
Every picture I've seen of Titan shows it enveloped in this orange fog.
That's another fascinating aspect. Titan's thick atmosphere teems with tiny particles called tholins, organic molecules born from the interaction of sunlight and methane. These tholins scatter sunlight, creating that permanent orange haze that we see.
So no standing on Titan and gazing up at a clear blue sky.
Not a chance. The haze is so dense that it obscures the surface from view. In fact, much of what we know about Titan's surface features comes from radar data collected by the Cassini spacecraft.
Ah, Cassini. That's the NASA mission that orbited Saturn for over a decade, right?
Yes. Cassini revolutionized our understanding of Titan. It completed over 120 flybys of the moon, capturing detailed images and collecting data about its atmosphere, surface, and magnetic field.
And didn't Cassini also carry a lander that actually touched down on Titan?
You're thinking of the European Space Agency's Huygens probe. It detached from Cassini and descended through Titan's atmosphere, successfully landing on its surface in 2005. It marked the first and only time a spacecraft has landed on a moon in the outer solar system.
Incredible. What did Huygens uncover during his brief time on the surface?
It relayed the first ever images from Titan's surface, revealing a landscape that was eerily reminiscent of Earth. It showed what appeared to be river channels and even pebble-like objects.
Pebble-like. What were those composed of? Rocks.
That's where things get fascinating again. They were likely chunks of water ice, frozen solid and rounded by erosion. Remember, on Titan water, ice essentially acts like rock due to the extreme cold.
Okay, my mind is officially blown. We've got a moon with methane seas and methane cycle and a landscape sculpted by frozen water. What's not to be fascinated by?
You probably wouldn't want to go for a swim in those methane seas. But from a scientific standpoint, Titan is an absolute gold mine. It's like a natural laboratory for studying prebiotic chemistry and the potential for life in an environment entirely alien to our own.
Wait, did you just say potential for life? Could there actually be life on Titan?
That's the million-dollar question, and it's a major reason why Titan has captured the attention of scientists worldwide.
Okay, I am officially hooked. Tell me more. What makes scientists think that life could exist in such a cold and seemingly hostile world?
It all boils down to Titan's unique chemistry. While incredibly cold and lacking liquid water on its surface, Titan possesses vast reserves of liquid hydrocarbons, the methane and ethane we've been discussing.
But life as we know it needs water, right?
That's true for life on Earth. But who's to say that life elsewhere must adhere to the same rules? Some scientists believe that methane-based life forms could theoretically exist utilizing hydrocarbons as solvents instead of water.
So instead of drinking water, these hypothetical titanian life forms would be sipping on methane.
In a manner of speaking, yes. It's a radical concept, but not as outlandish as it may seem.
Okay, but even if life could survive in methane, wouldn't the frigid temperatures pose a problem?
It certainly presents challenges, but life has an uncanny knack for adapting. We discovered extremophiles right here on Earth, organisms that thrive in extremely hot, cold, acidic, or alkaline environments.
So it's not impossible that some methane-loving extremophile could be hanging out on Titan.
Exactly. And then there's another intriguing possibility, a subsurface ocean.
Didn't you say earlier that all the water on Titan is frozen solid?
On the surface, yes. But beneath Titan's icy crust, evidence points to a global ocean of liquid water.
An entire ocean hidden beneath the ice. How is that even possible?
The prevailing theory is that tidal forces from Saturn generate heat within Titan's interior, keeping the water in a liquid state. Imagine squeezing a stress ball, the friction creates warmth.
So theoretically, you could have life in the methane lakes on the surface, A and D life in this hidden ocean beneath the ice.
That's the tantalizing possibility. It's like having two potential habitats for life on the same moon.
Okay, this is all mind-blowing, but how could life even get started in such different environments? What would they use for energy?
That's a great question. On Earth, most life ultimately derives its energy from the sun through photosynthesis. But on Titan, sunlight is weak and heavily filtered by that thick atmosphere.
So no photosynthesis for our hypothetical titanian life forms.
Not likely. But that doesn't rule out life entirely. Scientists have proposed that chemical reactions involving methane and acetylene, both abundant on Titan, could provide alternative energy sources.
So instead of soaking up the sun, Titanian life might be fueled by chemical reactions.
Precisely. It's a reminder that life might find a way to thrive, even in the absence of sunlight, utilizing energy sources we might not even consider on Earth.
This is all incredibly fascinating. I'm eager to learn more about this search for life on Titan, but we've covered so much already.
There's always more to uncover. And luckily, we have some exciting missions on the horizon that will help us delve even deeper into the mysteries of this incredible moon.
Oh, this is getting good. Tell me more about these missions. What's next for Titan exploration?
The one generating a lot of buzz is NASA's Dragonfly mission, slated to launch in 2027.
Dragonfly. That's a cool name. What will it do?
Imagine a drone-like rotorcraft navigating Titan's dense atmosphere, touching down on its surface and hopping from one location to another.
Wait, a flying drone on Titan? That sounds like something straight out of science fiction.
It does, doesn't it? But it's really happening. Dragonfly will be equipped with a suite of instruments to study Titan's atmosphere surface composition and search for signs of past or present life.
So it will be like a robotic explorer buzzing around Titan and collecting data.
Exactly. It will cover significantly more ground than a traditional lander, granting us an unprecedented view of Titan's diverse landscapes.
This is so cool. I can't wait to see what Dragonfly discovers. But before we get ahead of ourselves, let's go back to some of those big, unanswered questions about Titan. You mentioned earlier that scientists are puzzled by the source of Titan's methane. Where is all that methane coming from?
That's right. Methane is constantly being broken down in Titan's atmosphere by sunlight, meaning it should have been depleted ages ago, yet there it is, abundant as ever.
So something must be replenishing it.
Exactly. But that remains one of the biggest mysteries about Titan.
What are some of the leading theories?
One possibility is that there are active geological processes on Titan that are releasing methane from the moon's interior. Another theory postulates that there might be vast reservoirs of methane trapped beneath the surface, slowly seeping out over time.
So like a giant methane leak.
In a way, yes. But we still don't know for sure where it's coming from or how much is left.
And what about that subsurface ocean? How much do we know about it?
We're still putting the pieces together, but the evidence suggests it's a global ocean covering the entire moon beneath the icy shell.
Wow. But how deep is it? What's it made of?
Those are still open questions. Scientists believe it could be hundreds of kilometers deep and composed mostly of water, but with a significant amount of ammonia and salts mixed in.
So not exactly a pristine freshwater ocean.
Not quite. It's likely a very salty, ammonia-rich environment, which would present challenges for life as we know it. But again, who knows what kind of incredible life forms might be able to thrive in such a place.
I'm getting the sense that Titan is full of surprises.
You could say that again. And that's what makes it such a captivating place to study. It's a world that constantly challenges our assumptions about habitability and the possibilities for life beyond Earth.
Well, I'm convinced. Titan is officially my new favorite moon.
It's certainly a top contender. And who knows what amazing discoveries await us as we continue to explore this strange and wonderful world.
This has been an incredible journey into Titan. I'm feeling so inspired and eager to learn more.
Me too. It's moments like this that remind me why I love exploring the cosmos. There's so much out there that we don't know, so many mysteries waiting to be uncovered.
Well, I think it's time to wrap up part 1 of our Titan deep dive. Join us next time as we continue our exploration of this fascinating moon.
We'll delve deeper into the search for life on Titan, discuss the challenges and possibilities, and explore the future of Titan exploration.
And for all you space enthusiasts out there, make sure to follow and subscribe to Cosmos in a Pod and our YouTube channel for more cosmic adventures.
Welcome back to Cosmos in a Pod.
Last time we left off talking about the tantalizing possibility of life on Titan, and I have to say I'm completely hooked on this idea now. But how do scientists actually go about searching for life in such an alien environment? It's not like we can just send a rover over to scoop up some methane mud and see if anything wiggles.
You're right, it's a far more complex challenge than searching for life on, say, Mars, but that doesn't make it impossible. We just need to approach it with a different mindset.
So how do you search for life in a place like Titan?
It begins with understanding what conditions might be favorable for life, even if it's not the kind of life we're accustomed to here on Earth.
Right, we talked about the possibility of methane-based life forms using hydrocarbons instead of water, and then there's that potential subsurface ocean.
Exactly. Those are the two primary avenues of exploration right now for the methane-based life. The focus is on identifying chemical signatures that wouldn't be expected from typical geological processes.
So like some sort of telltale sign that something is messing with the chemistry of those methane lakes and seas.
Precisely, for example, if we detect unusual concentrations of certain molecules or witness unexpected chemical reactions occurring that could hint at something biological at play.
Like a methane-breathing microbe exhaling something we could detect.
That's the idea. And when it comes to that subsurface ocean, the challenge is even greater because it's hidden beneath a thick shell of ice.
So how do we even get to it? Drill a hole through the ice?
That would be ideal but incredibly difficult with current technology. For now, the best approach is to study Titan's gravity and magnetic fields, looking for subtle variations that might reveal the ocean's presence and composition.
Like using a giant planetary scale scanner to see what's beneath the surface.
It's a good analogy. And there's also the possibility of studying plumes of water vapor that might be erupting from the ocean into space, similar to what we've observed on Enceladus, another one of Saturn's moons.
Okay, so there's some clever strategies to potentially detect life on Titan, even if it's hiding deep underground. But realistically, finding actual living organisms is going to be a long shot, right?
It's definitely a challenge, but not insurmountable. Remember, we're merely scratching the surface when it comes to comprehending the full diversity of life in the universe.
It's true. I mean, look at all the bizarre and wonderful creatures we've discovered in the deep oceans here on Earth, living in environments we once thought were completely inhospitable.
Exactly. Life finds a way to adapt to even the most extreme conditions. So if there's even a slim chance that life could exist on Titan, I believe it's worth pursuing.
Absolutely. And this Dragonfly mission sounds like a major step in the right direction. I can't wait to see those aerial views of Titan's landscape.
Me too. And just imagine the data it will collect. We'll be able to analyze the chemical composition of the atmosphere and the surface materials. Hopefully, we'll also get a clearer understanding of what's happening beneath that icy shell.
It's like sending a mobile laboratory to another world.
It really is. And while Dragonfly's primary mission is to study prebiotic chemistry and habitability, it could also stumble upon some unexpected discoveries that completely reshape our understanding of Titan.
You never know what you might find when exploring the unknown.
That's what makes it so exhilarating. And speaking of the unknown, we still have some major mysteries to unravel about Titan, like that whole methane source conundrum. Where is all that methane coming from?
Yes, that's been bugging me. It seems like a crucial piece of the puzzle. What are the leading theories?
Well, one theory suggests that the methane is being released from Titan's interior through cryovolcanoes.
Cryovolcano. Okay, now you have to explain. Are those like ice volcanoes?
Exactly. Instead of erupting with molten rock, cryovolcanoes spew out icy materials like water, ammonia, and methane.
So picture these giant ice geysers erupting with methane. That would be something to see.
It would indeed. However, we haven't found conclusive evidence of cryovolcanic activity on Titan just yet. It's still a hypothetical explanation.
Right, so what's another possibility?
Another theory proposes that the methane is trapped in clathrate hydrates beneath the surface.
Clathrate hydrates. Those sound a bit complicated.
They're essentially icy structures that can trap methane and other gases within their crystal lattice. Imagine them like tiny methane cages.
Interesting. So these methane cages are buried beneath the surface, and somehow the methane is escaping.
That's the idea. It's possible that geological processes like faulting or tectonic activity could be fracturing these clathrate hydrates and releasing the methane.
Okay, that makes sense. But I'm guessing we don't know for sure if this is happening either.
Right. It's another piece of the Titan puzzle we're still trying to solve.
Is there a third option? Or are we stuck with cryovolcanoes and methane cages for now?
Well, there is one more possibility, although it's a bit more speculative.
I'm all ears. Speculation is half the fun of exploring the unknown.
Some scientists have proposed that the methane could be biological in origin.
Hold on, are you suggesting that there might be methane-producing life forms on Titan?
It's a long shot, but it's not entirely outside the realm of possibility. Here on Earth, we have methanogens, microorganisms that produce methane as a byproduct of their metabolism.
So you're saying there could be alien methanogens on Titan pumping out methane and keeping the atmosphere replenished?
It's a bold hypothesis, but one that we can't dismiss until we have more data.
Wow. So we have three main theories for the methane source.
Mhm.
Cryovolcanoes, clathrate hydrates, and, wait for it, alien microbes.
Exactly. And each of these possibilities has profound implications for our understanding of Titan and its potential for life.
Okay, my head is spinning with all these possibilities. Cryovolcanoes, methane cages, alien microbes, and a hidden ocean that might harbor life. What's next? Do we just have to wait for Dragonfly to get there and give us some answers?
Dragonfly will certainly be a game changer, but there's a lot of research happening here on Earth that can help us prepare for its arrival.
Like what?
For instance, scientists are conducting laboratory experiments to simulate the conditions on Titan. They're studying how organic molecules interact in the presence of liquid methane and ethane.
So like creating mini Titans in a test tube.
You could say that. These experiments can help us better understand the chemical reactions that might be taking place on Titan, both geological and potentially biological.
That's clever. And what about the subsurface ocean? Any plans to explore that directly?
There have been proposals for future missions to Titan that would specifically target the subsurface ocean.
A submarine on Titan. That would be incredible.
It would be a technological marvel, but it's not entirely out of the question. We already have robotic submarines exploring the depths of our own oceans, so adapting that technology to the extreme conditions of Titan's subsurface ocean is a fascinating possibility.
Okay, submarine on Titan is officially going on my space exploration bucket list. But before we get carried away with future missions, I want to circle back to something you said earlier about the diversity of life in the universe. It's just so mind-blowing to think that life might exist in a place as different from Earth as Titan. It really makes you question everything we thought we knew about what's possible.
Absolutely. We tend to be very Earth-centric in our view of life, assuming that it requires liquid water, sunlight, and a specific range of temperatures. But Titan shows us that there might be other pathways to life, other ways for organisms to harness energy and thrive in environments that we might consider inhospitable.
It's a humbling reminder that we're probably only just beginning to understand the true potential for life in the universe.
Precisely. And who knows what other strange and wonderful life forms might be out there waiting to be discovered.
Welcome back to Cosmos in a Pod.
It's great to be back for the final part of our deep dive into Titan.
We've covered so much ground, from those methane lakes and seas to that potential subsurface ocean and even the mind-boggling possibility of alien microbes.
It's been quite a journey, but before we wrap up, I think it's worth taking a moment to revisit two missions that completely revolutionized our understanding of this fascinating world.
You're talking about the legendary Cassini and Huygens, right? The dynamic duo of Titan exploration.
Exactly. The Cassini-Huygens mission, a collaboration between NASA and the European Space Agency, was a monumental achievement in space exploration.
Cassini was the orbiter gracefully circling Saturn for over a decade, and making numerous flybys of Titan and Huygens, the intrepid little lander, actually dared to touch down on Titan's enigmatic surface.
Precisely, Cassini launched in 1997, arrived at Saturn in 2004, and spent the next 13 years diligently studying the ringed planet and its many moons, including, of course, our star of the show, Titan.
And during that time, it made over 120 close flybys of Titan right, gathering an incredible amount of data about its atmosphere, surface, and magnetic field.
Absolutely. Cassini was equipped with a suite of sophisticated instruments, including radar, which allowed it to pierce through Titan's thick haze and map the surface in extraordinary detail.
So we have Cassini to thank for those breathtaking images of Titan's lakes, rivers, dunes, and mountains.
Indeed. Cassini revealed a world that was both strangely familiar and utterly alien, with Earth-like features sculpted by exotic materials like liquid methane and frozen water ice.
It's just remarkable how a world so different from our own could have such familiar processes happening.
It truly is, and it begs the question what other Earth-like processes might be occurring on other worlds that we haven't even discovered yet. The possibilities are endless.
Okay, so Cassini was the tireless workhorse, diligently orbiting Saturn and making those close passes of Titan. But then we have Huygens, the brave little lander that dared to go where no spacecraft had gone before.
Ah, yes. Huygens, named after the Dutch astronomer Christian Huygens, who discovered Titan back in 1655, its mission was a truly remarkable feat of engineering.
It hitched a ride to Saturn on board Cassini, and then detached in December 2004, beginning its solo mission to Titan's surface.
And after a suspenseful descent through Titan's dense atmosphere, Huygens landed safely on January 14, 2005. It marked the first and only time a spacecraft has landed on a moon in the outer solar system, a truly historic moment.
That must have been an incredible moment for the scientists and engineers who had dedicated so many years to this mission.
It was a triumph of human ingenuity and a testament to our relentless curiosity to explore the unknown.
So what did Huygens discover during its short time on Titan's surface?
Well, despite only operating for about 90 minutes after landing, Huygens transmitted a wealth of data back to Earth, including the first ever images from the surface of a world in the outer solar system.
I remember seeing those images. They were grainy and a bit blurry, but absolutely captivating nonetheless.
They were, and what they revealed was a landscape that looked surprisingly Earth-like, with what appeared to be riverbeds, shorelines, and rounded pebbles, all sculpted by the flow of liquid methane.
It's mind-boggling to think that a world so cold and seemingly alien could have such familiar-looking features.
It is, and Huygens also measured the composition of Titan's atmosphere during its descent, confirming the presence of nitrogen, methane, and a variety of other organic molecules.
So Cassini and Huygens working together gave us an unprecedented glimpse into this strange and wonderful world.
They did, and their discoveries have sparked our imaginations and inspired countless scientists to continue exploring the mysteries of Titan. Who knows what other secrets this moon holds waiting to be uncovered by future missions like Dragonfly?
This has been an incredible deep dive into Titan. I feel like I've learned so much, and my curiosity has only grown.
The same here. Titan is a world that never ceases to amaze, and I have a feeling we'll be talking about it for many years to come.
Well, on that note, I think it's time to wrap up our journey to this fascinating moon and our exploration of the possibility of life beyond Earth.
But the exploration of the cosmos continues. For all you space enthusiasts out there, make sure to follow and subscribe to Cosmos in a Pod and our YouTube channel for more cosmic adventures.